Before we explain Newton's laws, the first question we should ask is, who is Isaac Newton? Isaac Newton was an English physicist, mathematician, and an astronomer. He was born in 1643 in the town of Woolsthorpe by Castleworth. He died on March 31st, 1727 at the age of 31. Now that we know Newton, we can get going with his laws. We all know how the legend of how Isaac Newton was leaning against the apple tree and how the apple fell on his head, then he suddenly thought of the 3 laws of gravitation. Well, let's get to his first law. Newton's first law is an object at rest will stay at rest, and an object in motion will stay in motion with the same speed in the same direction unless acted upon an unbalanced force. For example, when come to a stop in a car, the seatbelt, the opposite force, stops you from leaning forward. Another example is when a hockey puck is sliding on ice, it will eventually stop because of the rough ice. But if the ice is smooth, it will slide for a longer period of time. The last example of Newton's first law is when you are kicking a ball in space, it will keep on going because there is no gravity, friction, or air resistance. It will only stop going in one direction if it hits something, like a meteor or the gravity field of another planet. Newton's second law is when a force acts on an object, the object accelerates in the direction of the force. Newton's formula for the second law is F equals ma, which I don't really agree with that, but I'll talk about it later on. So back to Newton's second law. For example, as a bike speeds off downhill, the force of gravity pulling the bikes down the slope makes it accelerate. Here's another example of Newton's second law. We all know the game Agario, right? Well, when you first get started, you are small, and you move around pretty fast. But as you get bigger, you'll notice you'll go more slowly, because you have more mass. Here's one last example of Newton's second law. If you and your friend are having a race to see who will push the item the fastest, and you have a small lawnmower and your friend has a car, who do you think will win? Obviously you, because the lawnmower weighs less than the car, which means you don't have to push with more force than the person pushing the car. Here is Newton's third and final law. For every action, there is an opposite and equal reaction. For example, tires of a car push back against the road while the road pushes forward. Okay, so here's another example. For instance, if you jump off a boat into water, you will be pushed forward towards the water. The same force you use to push forward into the water will make the boat go backwards. When air rushes out of a balloon, the opposite reaction is that the balloon... So I know what you're probably thinking. Do we really need all 3 of Newton's laws? Because you can be at rest and stay at rest, or you can be in motion and stay in motion. But in either case, there's no external force on you. You might realize that Newton's first law is a special case of Newton's second law. So we can combine those two and simply say that the net external force, which can be 0, is the time rate or change of momentum. But remember, there's that third law too. That external force that changes your momentum is coming from somewhere. And there is an equal and opposite force on whatever thing pushes you. And therefore, by the second law again, it gives an equal and opposite change in momentum. So what do we learn from this? Momentum. If you look at all the objects exerting forces on each other, it's conserved overall. So there's this one concept, the conservation of momentum, that when you combine it with the definition of momentum, gives you all of Newton's laws. And one last thing, remember when I said I didn't agree that F equals ma isn't quite right? Because when you get close to the speed of light, you can't accelerate up to it, no matter how much force you have. But you can still increase your momentum. And the time rate of change of momentum is still equal to the force net on you. Does this mean Newton anticipated Einstein's theory to special relativity? We'll never know, but all of the ways for Newton to phrase the second law, he sure did pick an interesting one.